think of the term work, and what do you think of when you hear that word? Cleaning up your room, homework, mowing the lawn, doing the dishes. Let's look here and figure out who's doing more work. So we have Ricky and Pam, and they are stocking shelves. Ricky stocks 10 shelves in the time it takes Pam to stock 5. Who did more work, Ricky or Pam? Of course, Ricky. He did more work because he moved more objects from the boxes to the shelves. So Ricky did more work here. Now we have Stan and Sarah, and they are doing their morning workout. He runs a mile in 6 minutes. Sarah runs the same mile in 10 minutes. Who did more work? If you said Stan, nope. They did the same amount of work. They both ran a mile. However, Stan used more power because he ran the mile in a lot less time. Work and power are used to refer to a variety of things. They have very specific meanings, however. Let's learn more about those. Work. Energy is defined as the ability to do work. So what is work exactly? Work is when a force acts on an object causing it to move. That's when we say work has been done. So anytime that we are applying force, which remember is a push or pull, so we're pushing or pulling something and that object moves, we're doing work. We have 3 components of work: force, movement, and cause. It's a process of causing matter to move against an opposing force. Let's say that I am pushing up against one of the walls of my house. Am I doing work? Well, I'm definitely applying force because I'm pushing. But is there movement? I am not Superman. I cannot move a wall in my house. So no, because there's no movement, there is no work being done. We have learned that objects will move when an unbalanced force, like pushes or pulls, are applied. The process of applying the force can be called work if force, movement, and cause are all present. So let's talk about work versus no work. Picking up a laundry basket. Is that work or not work? Picking it up. Is she doing a push or a pull to cause force? Does she have movement? Does she have cause? If you answered yes to all of those, the answer is work. If you answered no to any of them, it's not work. Yes, she's pulling in an upward movement, so that would be work. A horse is pulling a carriage on the street. Now, remember, force, so push or pull, movement, and cause. Is the horse applying a force? Yeah, it's telling us it's pulling. And is it pulling it? It's pulling it down the street, which makes me say that yes, there is movement. Awesome. A man pushing a shopping cart down the aisle. Is there force? Is he pushing or pulling? He's pushing. And is there movement? Obvious by the picture that he is moving. So yes, he is moving, which means he is doing work. Holding a barbell in one place. Is he pushing or pulling? Nope. Is there movement? Nope. So would this be work? No, can't be work. He's not pushing or pulling and he's not moving. a weightlifter who's trying to lift a weight that is too heavy for him. Look, it hasn't moved off the floor yet. Is he doing work? It sure looks like it. But he's not, because there's no push or pull and there's no movement. Let's calculate work. Work is equal to force times distance. Work can be measured in joules, or J, and force is measured in newtons, N, and distance is measured in meters, M. So our equation, work equals force times distance, also could say J equals N times M. And that would give us this formula. Joules equals newtons times meters. Now this formula is only true when we are doing work on a flat surface. When there are angles that are involved, there's an extra step added. So we are assuming for this purpose of this course only that all surfaces are on a flat surface. Remember that. When we have angles, there is an extra step. So for our course, we're talking about flat surfaces. And then you need to go into the you try area and figure out these formulas. This is very important for your test. Hint, hint, very important for your test. Come back and do the you try portion. So let's go through the example together. A horse uses 250 newtons to pull a cart through 10 meters of mud. Here's how to calculate how much work the horse has done. So the work, which is measured in joules, equals 250 newtons, which was the force, remember that, times the amount of the motion, which was 10 meters, and it comes up to 2,500 joules. So the work done was 2,500 joules, 2,500. So you need to do these scenarios on your own. It's very important that you do this part. I would suggest go ahead and push pause on this video right now and come back after you've worked these formulas. All right, I'm glad you came back and did those formulas. I'm sure you have a better understanding now of the calculation of work. Now, what is negative work? It might make you think of your really lazy friend that just sits on the couch all day long and does absolutely nothing. But it really is a term that is used when work or when force acts upon a moving object to stop or hinder the movement. So we talk about, so here's a hockey player and he skids to a stop on the ice. So that would be negative work, stopping it. These army are stopping or pushing against the riders, and the riders pushing against them. The cops' shield is example of negative work because they're coming up against something that's stopping them. And then, of course, being tackled would be another example of negative work. So now our running back is being stopped by a tackle. So he's got negative work. We talk about that in football as negative yards. So we know what work is. Now what is power? Power is the rate at which work is done. Simple, right? How fast can you do something? How quickly can you do something? What's the rate at which you can do it? When you increase your power, you increase the amount of work that can be done in a certain amount of time. Or do the same amount of work in less time. That would be how you are increasing your power. If you have to cut a lot of wood for a project, which would you rather use? A hand saw here or a chainsaw? I think personally, if I did do a lot of it, I'd choose the chainsaw. Exactly. We're trying to get the work done faster, so it would mean increasing our power. So increasing power then would be using a power tool instead of a hand tool. Let's calculate power. Power equals work divided by time. Very simple. How much work can you do in a given amount of time? The unit that we use to express power is watts. 1 watt equals 1 joule. Remember, that's the work. Work must be measured in joules and in time in seconds in order to calculate watts. So watts equals joules divided by seconds, and that's going to give us watts. So W equals J over S. The expression for power is work divided by time. And since the expression for work is force times distance, the expression for power can be rewritten as force times distance divided by time. And then since the expression for velocity is distance divided by time, the expression for can also be written power equals force times distance divided by time. And it can also be rewritten as power equals force times velocity. Let's look at a few examples of how the amount of power and work can be done in each. So you need to come back into the lesson, put me on pause, and do both the examples and the you try. And when you come back, we will finish up with the lesson for 106. Awesome. You now have the information that you need to complete the 1.06 worksheet. So go into the worksheet and complete it with the knowledge that you have now gained. After you've completed that, call your teacher for your discussion assignment so you can take your quiz. Congratulations on finishing your Module 1.